So, what is a quadratic equation? Well, we already mentioned it in the last video that a quadratic equation is an equation in which our highest degree variable term has an exponent of 2. So this is a quadratic equation. It's probably one of the simpler ones. And if we ask someone to solve it, more often than not, they say x is equal to 3. And they are incorrect. X is not equal to 3. X is also equal to negative 3. So there's two ways to solve this quadratic equation. Let's take a look at the one of the methods. Try and use the eraser. One of the methods. One is to use the inverse operation of squaring. Now the inverse of squaring a number would be to take its square root. Now the square root of x squared is equal to x. This is what most students do. And the square root of 9 is not 3. It's both positive and negative 3, which means the solution set for this quadratic equation is 3, negative 3. Alright, so it has two solutions, and we can check them. If we substitute 3 into the equation, 3 squared is 9. So 9 is equal to 9, and that checks out. If we substitute in negative 3, negative 3 times negative 3 is 9, so 9 equals 9. Okay? The other method is easier, and we'll actually take a look at it in a minute, and then we'll come back here. Alright, so I'm going to set this up to be solved again in a minute. Okay, so we're being asked to solve the quadratic equation x squared equals negative 5x minus 6. If you remember from your days in Algebra 1, to solve a quadratic equation you want it to be equal to 0. You might not remember why. So let's first make it equal to 0. So we're going to add 5x and 6 to this side to move everything over here. So whatever we do to one side, based on the previous video, said we need to do to this side. So our new quadratic equation is x squared plus 5x plus 6 equals 0. Okay, so I forgot. Having the equation equal to 0 is supposed to make it easier to figure out what numbers solve this. So x should be equal to something, possibly even two somethings. I can't figure out what numbers go in here to make it equal to 0. I'd be guessing if I tried at this point. I think I remember from when I took Algebra 1 that I was told if you factor it, it will become clear. So let's take a look. That becomes x plus 2, and that becomes x plus 3 equals 0. And supposedly in this form it's actually quite easy to guess what numbers will make this equation work. And that's true. If I plug in negative 2 here, negative 2 plus 2 equals 0. 0 times that, I don't even care what this is. If I plug in 2 here, it's 2 plus 3 is 5. So I'll get 0 times 5, which is equal to 0. So negative 2 is one of my solutions to this equation. We can check that back in the original one. Negative 2 squared is equal to negative 5 times negative 2 minus 6. Let's check. That's 4. This is 10 minus 6. We get 4 equals 4. So that's one solution. Looking back here at factored form again, I can see if I plug in negative 3 here, this piece will be equal to 0. And 0 times whatever this is will be 0. So just out of curiosity, negative 3 plus 2 is negative 1. So we get negative 1 times 0, which is 0. So that happens when x is equal to negative 3. Now some teachers teach you to use something called a t-chart. And you say x plus 2 equals 0, and solve for x. You'll get x equals negative 2. You can solve for x plus 3 equals 0, and you'll find x is equal to negative 3. Same thing. You don't have to do that if you can tell what number you plug in at this point. Let's test the other value. Supposedly negative 3 squared will also be equal to negative 5 times negative 3 minus 6. So that's 9, which is equal to 15 minus 6, and that is true. 9 is equal to 9. So let's go back to the previous example, because we didn't factor to solve that, but we can. Okay, so again, most students often miss the negative factor, so let's do that here. We will subtract 9 from both sides. We will get x squared is equal to minus 9 is equal to 0. This is the difference of squares, so we get x plus 3 and x minus 3 equals 0. Okay, looking at this, we can see that substituting a negative 3 will make this factor 0, so the whole thing becomes 0. And plugging in positive 3 here will make the entire thing 0. So positive 3 will also be a solution here, so our solutions are 3 and negative 3. Either way we do this. Alright, let's take a look at another example. This is actually not a quadratic equation, but if we can factor it, we can actually determine what its solutions are. It's a cubic equation, so it should have 3 solutions. It is currently set up in the groupings that I would want, so let's factor this by grouping. Here we get a GCF of 4x squared, which will leave us with 2x plus 1. And here we have a GCF of negative 9, leaving us with 2x plus 1 equals 0. Now the equals 0 doesn't disappear. We don't change things, we can just move them around a little. So these two terms have a GCF of 2x plus 1, so we'll factor that out. And the remaining factor here is 4x squared minus 9 equals 0. Now this can actually continually be factored here. That will factor because it's a difference of squares. This will just come down, doesn't change. That is 2x plus 3 and 2x minus 3. Now none of these have any GCFs, so our solutions are the values that make these equal 0. Now this is where that t-chart kind of would come in handy, and that's based on, let's move this over here. This t-chart would come in handy at this point because we'd be able to figure out what values plug in here more easily. I'm telling you, based on this in advance, that the 3 solutions to this cubic equation are negative 1 over 2, negative 3 over 2, and positive 3 over 2. And I'm going to prove that to you now. So in this case, this is kind of needs a three-way chart, a t-chart. We have 2x plus 1 is equal to 0, because if this piece is equal to 0, then the entire thing is equal to 0. By solving this, we get 2x is equal to negative 1, and x is equal to negative 1/2, which is what I said it would be. We have 2x plus 3 equals 0 is another possibility, so if this one's not equal to 0, it'll also be solved if this one is. So we'll get 2x is equal to negative 3, x is equal to negative 3 over 2, so that's the other solution. And last but not least, we have 2x minus 3 equals 0, we get 2x is equal to 3, and x is equal to 3 over 2. So now that we've learned how to use grouping, we can actually solve a lot of more interesting equations. We can solve quadratics, we can solve cubics, we can solve quartics, we can solve 5th degree equations, just because we have more ability to factor now. Another example I didn't put up in the slides would be this one. We have x, let's say, x squared minus 3x equals 0. This would be a different equation entirely. If you factor that, you get x and x minus 3 equals 0. So the solutions to this would be, when x is 0, this part is 0. 0 times negative 3 will be 0. Or if x is 3, then 3 times 3 minus 3 is 0. So both of those are solutions. Let's look at a fourth example, which actually is a rational equation because it has fractions. This came out of the New York State Algebra Regents. Currently, we don't have the same denominator, so let's make that happen. We're going to multiply the denominators by each other, so we'll have the same denominators. Whatever we do to the top, we do to the bottom. So over here, we need an x minus 4. I probably shouldn't write it that way. Whoops, I went too far back. Oh well, whatever. Multiply the numerator and denominator of the first fraction by 3. And we're going to multiply the numerator and denominator of this fraction by x minus 4. Okay, so we get 6x minus 9 equals 6x minus 9 over 3 times 4 minus x minus 4. Times x minus 4 equals 2x minus 8 over 3 times x minus 4. Now I could have distributed these out, but we're back where we were in the previous video when we have a fractional equation. If all of our decimals are the same, we can simply cancel them out. But we do need to notice that 4 is actually a excluded value in this equation, so let's keep that in mind when we continue to solve it. So now we have 6x minus 9 is equal to 2x minus 8. Let's solve the equation. We will add 9 to both sides. Well, I wrote that down incorrectly. That would be an 8. That would have been weird. Add 9 to both sides, and we get 6x equals 2x plus 1. We'll subtract 2x from both sides, and we'll get 4x equals 1, which means x is equal to 1/4. So checking that in the original problem, we have 2 times 1/4 minus 3 over 1/4 minus 4 should be equal to 2/3. Let's check. So this is 1/2 minus 3 is 2.5. This is 1/4 minus 1/4 minus 4. This doesn't look right. Did I make a mistake somewhere? The denominators are the same. Because this is going to become a negative value, but this obviously is not negative, so we have to check that more carefully. Okay, multiply them by each other. Those cancel out. That's 1. That is 4. Not sure where I messed up here. Messed up somewhere. I'm going to figure it out. It's not necessarily bad for you to see me try and figure this out. Oh, wait, that is negative 2.5. This is 1/2. This is negative 2.5. This is negative 0.25, so that is negative 3.75, which is equal to 2/3. Okay, so I'm not sure if these are equal off the top of my head. Let's use my calculator real fast, and we'll see that 2.5 negative divided by 3.75 negative is equal to 0.666666, which is the same thing as 2 divided by 3. So this is 0.6 repeating is equal to 0.6 repeating. So using the calculator, we see that this is equal to 0.6 repeating, and so is this. So they are equal. Thank you.